Hey guys, we're gonna go over the semester 2 exam review. Alright, so problem number 1 says to evaluate. Okay, so remember what this symbol means. It means the sum of. Okay, so wants us to find the sum of this expression from when k equals 1 to when k equals 7. Okay, so this is a geometric situation, okay? Because it's being raised to a variable exponent. You know, there's a variable in the exponent. That means this is geometric, okay? So we have a formula that allows me to find the sum of a geometric formula. It is a sub 1 times 1 minus r to the n divided by 1 minus r, okay? So then the trick to remembering the trick to doing this isn't just remember what is a sub 1 and what is r. Alright? A sub 1 is your first term, which is just this number right here. So it's 4. And then r is the number that is the base that has the variable exponent. So r is 1/2. So raised to 1/2. Okay, n is the total number of terms, which was 7, divided by 1 minus r, so 1 minus 1/2. Now the rest of this is just a plug into a calculator kind of problem. So we pull up our handy dandy calculator, we turn it on, we do 4 times, okay, now I suggest you use your alpha y equals ability here. I have to do some weird stuff because I do not have the alpha y equals ability, okay, divided by, I know that's just going to be 0.5, close, press enter. And I get 7.9375. So the sum of all this is approximately, or is equal to, not approximately, 7.9375. Alright? I suggest you try to do number 2 before watching this next part, because it follows the very, very same idea as this problem does. Okay? So, our first term is -3. Our r is 1/2 again, so 1 minus 1/2 raised to the total number of terms, which is 8, all divided by 1 minus 1/2. Okay, so I'm now ready to throw this in my handy dandy calculator. So -3 times 1 minus, I'll throw this guy in parentheses this time, and I don't think that's necessary. I just like to be redundant if I have to, you know, just to be on the safe side, divided by, I know that 1 minus 1/2 in the denominator is 0.5. Close it. And I get -5. I'm going to round this one to the thousands place, 977. Alright, and there we go, -5.977. Okay, I hope that's what you got when you tried this problem without me. Okay, moving on. Represent each sequence using a recursive formula. Okay, so you got to remember that recursive formula is always a sub n is equal to a sub n plus 1 if it's arithmetic, or a sub n is equal to, my brain's blanking. A sub n is equal to, wait. I wrote that wrong. Sorry. Let me start over. Sorry. Arithmetic is a sub n plus 1. So that means the next term is equal to a sub n plus r. So hopefully you didn't write that in pen, okay? So that's how that one is. So it's the next term is equal to the current term plus the common difference. That's arithmetic, okay? Geometric is a sub n plus 1. So it means the next term is equal to a sub n times r. Alright? I apologize, I goofed that up. Okay? So this is arithmetic, this is geometric, recursive. Okay? So first you have to look at this sequence and determine, is this arithmetic or is this geometric? So we go 6, 3, 0, -3, -6. Clearly we're going down by -3 each time, so that makes it arithmetic. So you can say a sub n plus 1 is equal to a sub n, and then r is just a -3. Bam, I'm done. Okay, so let's go look at number 4. 3, 3 halves, 3 fourths, 3 eighths, 3 sixteenths. Well, what am I doing each time? I'm multiplying by 1/2 each time. Excuse me. So then I can say that this guy is a sub n plus 1 is equal to a sub n times 1/2. All right. Moving on to our next problem. Okay. Next problem, which is number 5. Represent each series using the sigma notation. Okay, so remember, sigma is this symbol right here. And we just say n equals 1. And you'll notice this goes dot, 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 so it means it never ends. So now we have to look and ask ourselves, what's going on with this guy? How am I going from 3/5 to 6/5 to 9/5? Well, what is happening each time? Well, this one's actually kind of a tricky problem, okay? But remember that you're supposed to have an n involved, okay? So that means you're doing 3/5, and then you're either adding something or you're multiplying by something. Well, what would be the first n? N would equal 1, right? So what's 3 times 1? 3. So 3 times 1 over 5 would be 3/5, right? Okay, so what would be our next term? This would be term number 2, right? This was term number 1. This would be term number 2. So it becomes 3 times 2 over 5. And what term would this be? This would be our third term, which would be 3 times 3 over 5. So in other words, I can say that this is 3n over 5. Okay, that was a tricky one. You might want to kind of take a moment and really think about that. All right. Moving on. Calculate the infinite sum if possible. Okay, so it's important to remember that you can only have an infinite sum if it's geometric and if r is between 0 and 1. Okay, so 64, 16, 4. Okay, how am I going down each time? That's right, I'm dividing by 4 each time. So what is dividing by 4 the same thing as multiplying by? That's right, 1/4. Dividing by 4 is the same thing as multiplying by 1/4. So r is 1/4. Okay, so then it is possible to calculate the infinite sum. Now, you may have forgotten this formula, which is completely okay. I forget it legitimately all the time. Okay, you take your first term, and you say a sub 1 over 1 minus r. This is the formula for infinite sum if possible. Okay? So, and it is possible because my r is 1/4. All right? So, I can say that my first term is 64 over 1 minus 1/4. And now we are ready to do this in the calculator. So we just simply say, if I could get this turned on, 64 divided by 1 minus 0.25, press enter, and we get 85.3. Repeating, so I'm just going to put a little bar over it. 85.3 repeating. Okay? Alright, number 7. Write the binomial expansion using Pascal's triangle. Okay, so first, it's important to remember what Pascal's triangle is. Pascal's triangle is where you start with 1, and that's row 0. And then you go 1, 1, and that's row 2. And then you go 1, 2, 1, because you added these two 1s to get here. So that's this is row 2 now. And then row 3 is 1, add these two together, 3, add these two together, 3, 1. So now that's row 3. So row 4 is 1, 4, 6, 4, 1. Okay, so now I can say 1 times something plus 4 times something plus 6 times something plus 4 times something plus 1 times something. So what you do is you take your first term and you raise it to that entire power. So we're going to have 3x being raised to the 4th power. And then what's going to happen next is we're going to take our next, we're going to keep 3x, but instead of being raised to the 4th power, it's now going to be raised to the 3rd power. I go down by 1 power. And then it's time for me to bring in my second term, the negative 2. So I say negative 2 to the 1st power. So the powers still add up to be 4. So then I say 3x to the 2nd power, negative 2 to the 2nd power. Then I say 3x to the 1st power, and I say negative 2 to the third power. And then last but not least is negative 2 to the fourth power. Okay? So now we're just going to go simplify. 3 raised to the fourth is 81. X to the fourth is x to the fourth. Times that by 1. It's just still 81x to the fourth. Okay? Plus, okay, 3 to the third is 27 times the negative 2 times 4. So 27 times negative 2 times 4 is negative 216. So negative 216 x to the third. Okay? Next one is 6 times 3 squared times negative 2 squared. Well, I know negative 2 squared is 4. I know 3 squared is 9. So I have 6 times 9 times 4. And that's 216. But this time you just have x squared, because that's all that's happening to the x. It's just getting squared right here, see? Alright. This time we're going to have 4 times 3 to the first times negative 2 cubed. Okay. Negative 2 cubed is negative 8. Negative 8 times 3 is negative 24. Negative 24 times 4, I'm not sure what that is off the top of my head. Some of you brighter students out there can beat me on that. Negative 96. So I can say negative 96, and then that's just going to be x to the first. And then negative 2 to the fourth is 16. 16 times 1 is 16, so plus 16. And there you go. That's all you can do on this problem. Okay? Alright. Problem number 8. Find the domain and range of the function y equals negative square root of x minus 4. Okay. So if you remember what a square root graph looks like, okay, so a square root graph, assuming there are no transformations, this is the parent function, looks like that. But there are 2 transformations here. I mean reflected across the x-axis, and I'm going down 4. I'm sorry, right 4. So the actual graph for this guy looks something more like this. So, what is the domain? Well, the domain is going to be from 4, and then it goes to the right forever. So that would be from 4 to infinity. And then the range is simply going to be from negative infinity to 0. So I say from negative infinity, that's a parenthesis by the way, to 0. And this is going to be a bracket. Okay? Alright. Problems 9 and 10. Let's see here if I can get this thing to let me scroll down. It's being a pain right now. There we go. Okay. So, it says problems 9 and 10 use this piecewise function. Okay. Find f of negative 1 and write your answer as a coordinate. Okay. F of negative 1. This means you want x to equal negative 1. Well, if x equals negative 1, which function do you use? Which part of the piece do you use? Which piece do you use? Let me ask that. Well, you got to use where x is less than 0 because negative 1 is less than 0. So we're going to plug in right there. So we're going to say negative 1 plus 1, which gives me 0. So then the coordinate is negative 1, comma, 0. Bam. Done. Okay? So now let's move on to our next problem, problem number 10. Find all the values for which f of x is equal to 0. So this one's saying, where does y equal 0? Well, you have 2 pieces here. So you need to set both of these pieces equal to 0. Okay, you need to set both of these pieces equal to 0 and solve for x both times. Okay, so we're solving for x here, so x is going to equal negative 1. Okay, we have to come back and check this to see if it makes sense. Okay, and then we're going to come over here and solve this. Guys, the easiest way to solve this one is just to add x squared over. So 5 is equal to x squared, and then take the square root of both sides. So the square root of 5 equals x. Now, who remember something? Anytime you take the square root of x squared and a number on the other side, this becomes plus or minus. Okay, so I really have 2 answers coming out of this one, a positive and negative square root of 5. Okay, so now we have to go back and check these answers. X plus 1, where did it come from? It came from this piece right here, right? What must x be less than in order to use this piece? 0. Is the answer negative 1 less than 0? Yes. So this answer works. Alright, let's go to these 2 pieces. Alright, well this piece, let's go to these 2 answers for this piece right here. Alright, to use this piece, x must be greater than or equal to 0. Well, a positive square root of 5 is definitely greater than 0. But is a negative square root of 5 greater than 0? No. So the only answer that you can get out of this is x equals square root of 5. And there you go. That's the work. So these two are the two places where y is going to equal 0. That means these are the two places where it's going to cross the x-axis. Okay? Moving on to our next problem. What transformation was made to create the following functions? Okay, I'm not going to write this out, but I will speak it. Alright, writing it out on my keyboard takes too long. Okay? So, y equals negative f of x minus 5. Well, since I have a negative being applied to the whole function, that tells me I'm reflecting the x-axis. That's one transformation, reflecting the x-axis. And since this minus 5 is inside the function with x, that means I am going to the right 5. Okay, so the two transformations for number 11 are reflects the x-axis, right 5. Number 12, negatives in front of the x, inside the function, so that means it reflects the y-axis. And the minus 5 is outside the function, so that means down 5. So it reflects y-axis because of this, and then down 5 because of this, because it's outside. Okay? So moving on. If I could get it to go down. The parent function, y equals fx, passes through the points 0, 1, 1, 2, 2, 3. After applying a transformation, the new graph passes through these new points. You can read it, I'm not going to read it out. What is the general equation represents the graph of the new coordinates? Okay. So guys, first, just think about like what happened. We went from 0 to negative 3. Just look at x's. We went from 1 to negative 2. We went from 2 to negative 1. What does it look like we're doing? Shifting to the left 3. Right? Like I'm subtracting 3 on the x, which means, oh well, I mean I'm going to the left 3 each time. Okay? So now, look at the y's. 1, 3, 2, 4. 3, 5. What does it look like I'm doing on the y's? Going up 2. So now I just need to take this function and make it do that. So I would just say y equals f of, okay, what does it mean to go left 3? How do you write that? Is it plus 3, minus 3, times 3, divide by 3? It's plus 3. That's right. X plus 3 means left 3, and up 2 means plus 2 outside the function. Okay? All right, moving on. Problem number 14. Problem 14. Let f of x equal x cubed minus 5 and g of x equal x plus 3. If h of x equal x cubed minus 2, identify how it was composed. Okay, so here's a trick you might want to think about. Look at what I want to have. I want to have this, okay? So that means I'm either doing f composed of g, that's not an O, that's composition, or g composed of f, okay? And it wants you to figure out which way. Is it f composed of g or is it g composed of f? Well, look at what you want. You want x cubed minus 2. So you want the x cubed to kind of stand alone. Okay? So think about that for a second. If you were to do f composed of g, that means you're taking x plus 3 and plugging it in for x right here. So that means you're going to have x plus 3 cubed minus 5. Okay, because you're taking that, you plug in for x. So, you know, x plus 3 goes in for the x. So now you get x plus 3 raised to the third power, minus 5, minus 5. Do you really think that x plus 3 cubed is going to yield just x cubed minus 2? Because that's x plus 3 times x plus 3 times x plus 3. So no, it's probably not. So I'm not going to work this out. I'm going to pause there. And I'm going to assume that that's not going to work. Now, if g composed of f doesn't work, I might go back. Okay? So instead, I'm going to try going another way. I'll do this one in purple to show you the difference. I'm going to take this x cubed minus 5, and I'm going to plug it into x right here, which is g composed of f. Okay? So instead of having this x now, I'm going to replace this x with x cubed minus 5. So x cubed minus 5, and then I can't forget the plus 3. That's a part of the g function. And then negative 5, positive 3, I can put those two together to get negative 2. And that's what I wanted, right? So h of x was composed by g composed of f. So that is our answer. Okay? Moving on. Number 15. Find the inverse function of f of x equals 3x minus 2. Okay, how do I find the inverse? How do I always start off finding inverses? Switch x and y. So this is going to become x equals 3y minus 2. Now it just wants me to solve for y. Add 2. So x plus 2 is equal to 3y. Okay? Excuse me. And then divide everything by 3. So bam, x plus 2 over 3 is equal to y. That is your inverse. So the inverse is f of negative 1 of x, that means inverse, is equal to x plus 2 over 3. Okay? Alright, next problem. Actually, it's not, the 15 actually lends weight to our next problem, which is apparently 18. Okay? It says, use f of x equals 3x minus 2 to find the inverse evaluated at 16. So guys, what we would want to do is we want to take the inverse of 3x minus 2, find that inverse first, and then plug in 16 into that inverse. Okay, but we already found that inverse on the prior problem, didn't we? Yeah, so I don't need to find it again. I already know it. It's x plus 2 divided by 3. So I can say x plus 2 divided by 3, that's the inverse, and it wants me to evaluate it at 16. So I can say 16 plus 2 divided by 3. So 16 plus 2 is 18. 18 divided by 3 is 6. And there we go. Okay, moving on to, next problem. Alright, describe the end behavior of the graph of the polynomial function using infinity notation. So you should remember that when we're doing end behavior, it's always as x approaches negative infinity. So that means as we look to the left of the graph, that's negative infinity, we want to know what does y approach. Okay? Approaches what? And then we look to the right of the graph. As x approaches positive infinity, y approaches what? Okay, and we look at the right of the graph. Okay, so it is entirely possible that you could just use a calculator and look and think. Alright? But there's a much faster way if you can just remember something. Look for the highest power of x. 4, right? Is that even or odd? It's even. So you know it should be up and up unless it's being reflected, hint hint, it is, then it's just simply down and down. So in this case, what we see here is that y, so it is down and down. So we say negative infinity, negative infinity. Okay? So let's go look at number 20. I suggest you pause and try this on your own. Okay? So hopefully you're just now starting the video back and you have a good shot at this one. Okay? So once again, all I would do is I would rewrite this part, but I would just leave off the negative infinity thing. Alright, because it's the same pattern every time. It's always, we look to the left of the graph, so as x approaches negative infinity, we say what is y doing? And then as x approaches positive infinity, so that's the right of the graph, what is y doing? Alright, well this one, notice my highest power is 7, so that's odd. So that is down, then up. Okay, unless of course the highest power is being reflected, but it's not because that's positive, so it stays down, then up. Okay, and there we go. Alright, moving on. Next problem. Okay. 21. Solve each polynomial. Guys, we're just going to use the calculator. Okay, so it says find the zeros. You should know that a zero is where I cross the x-axis. Okay, so I can just pull up my handy-dandy calculator. There's a way you can do this through, you guys might remember it was through synthetic division, you know, it's P over Q, you found out all the possible zeros, and then you started eliminating and you kept working through it. And that's perfectly okay. That's actually a really cool method that works. However, I know that we're just trying to, you know, get ready for our exam, so we're just trying to make sure we know what we're doing. Okay? So it looks like we have zeros here and here. Now, there are two ways to check this. Alright? The first way is to go to your table and just look to see if y is 0. Okay? So, I go over here. I see two zeros right here. At negative 3 and at 2. So I know I have zeros at x equals negative 3. Ooh, that's kind of hard to see. And x equals 2. Now, I have a highest power of 3, so I need 3 zeros. But go back to the graph real fast. If I can get it to go back to it. Okay, come on. Okay. What is it doing when it hits the 2? It's bouncing back up, right? What does that tell us about the 2? It has a multiplicity of 2, so that means it's really 2 of our zeros hidden in 1. Okay? So bam. So there's my 3 zeros, because I have 2 of my zeros at an x value of 2, and another one of my zeros at an x value of negative 3. Alright, let's move on to the next problem. I do suggest that you pause and try to do the next problem on your own, because it's very similar. So hopefully you just unpause, and now you are looking to see how I do it. Again, guys, I'm going to use the calculator, okay? So 15x squared plus 27x minus 10. Okay? So first I'm going to hit graph. I'm going to try to hit graph. Okay? And I obviously cross the graph here, here, and here. Okay? So I'm going to go to my table, and notice I'm crossing in 3 distinct places. And it looks like somewhere around 1, somewhere around 2, and somewhere around 5. Okay, so let's go check that out. Alright, oh, I have a 0 at 2. You see I have a y value of 0 right here. So I have a 0 at x value of 2. And then I have another 0 at an x value of 5. So I know x equals 2 and x equals 5. So there's one more 0 I'm not seeing though. Let's go back to the graph. So there was another 0 that happened before the 2, but it wasn't 1. So maybe what would that have been maybe? Well, you might be thinking it's probably 0.5. It probably was. It might be. How can I get that? I can use my calculator's second trace feature. 0. Press enter. It says left bounds. Okay, so first I have to make sure I find my cursor. Oh, here's my cursor. So if my 0 is right here, and I need to be to the left, is my cursor to the left of it right now, according to left bound? Yes. Press enter. Now I need to move my cursor to the right. Is my cursor now to the right of my 0? Yes. So I press enter. Guess I just press enter again, and I get an x value of 0.5. So my third 0 is happening when x is equal to 0.5. Alright, moving on. Next problem. 23. Describe the transformation to use. Excuse me. Oh, I need to learn how to edit so I can edit stuff like that out. But that's not going to happen on this video. I can tell you all that. So, let's see. Describe the transformation you use. I went from a 1 to a 7, from x to x plus 3, and I didn't have anything after the function. I have a plus 2. Well, I know that plus 2 out here means up 2. And I know the plus 3 next to the x means left 3. But what does the 7 mean? How would you change a 1 to a 7? Because you can't just straight add something. You know, that's not what's happening. What could I have done? That's right, I could have multiplied by 7, right? And that would give me a vertical stretch by 7. Okay. Alright, next problem. Find the coordinates of the removable discontinuity. Alright, this one is a doozy. To find the coordinates of removable discontinuity, first you need to factor everything, okay? So we factor and we factor and we factor till we die, okay? So x squared, negative 9, negative 9x squared, 0x. I'm factoring based on tic-tac-toe, where you put the quadratic term, the constant, multiply the 2 to get this. You put your linear term, which I don't have one here, so I just call it 0x. You need to find 2 numbers that multiply this, but add to this, and that's 3x and negative 3x. And then x squared and 3x, what they have in common? X. X squared and negative 3x, what they have in common? X. X times what is 3x? 3. X times what is negative 3x? Negative 3. So this gives me x plus 3, x minus 3. Okay. Now I need to go factor this denominator. Like I said, we factor until we die. Alright, so that gives me x squared, because factoring is life. Alright, so that gives us 12x squared. So we need 2 numbers that multiply to 12x squared but add negative 7x. Negative 4x and negative 3x. Very good. Okay. X squared and negative 4x have what in common? That's right, they have an x. X squared and negative 3x have what in common? That's right, they have an x. X times what is negative 4x? Negative 4. X times what is negative 3x? Negative 3. Go across, go across. So we get x minus 4, x minus 3. Now, you can only have removable discontinuity if there's something to cancel out on top and bottom. Is there something to cancel out in this fraction? Yeah, the x minus 3's. So now my new fraction is x plus 3 over x minus 4. So, to get your whole, that's removable discontinuity, first off, you take what you just canceled out, you set that equals 0. So x minus 3 equals 0. Okay? We're going to add the 3 over. This is the x value of your whole. X equals 3. That is the x value of your whole. Okay? So I say 3, comma. Okay? So now what you do to get the y value, you take this 3 and you plug it back into your new equation. So that's going to be 3 plus 3 over 3 minus 4. Well, 3 plus 3 is 6. 3 minus 4 is negative 1. 6 divided by negative 1 is negative 6. So, bam. That is my whole. That is the coordinates of my removable discontinuity. Okay? 25. Find the slant asymptote. Alright, so this is how you find a slant asymptote. First off, slant asymptotes only exists when the degree of the numerator is higher than the degree of the denominator, which is happening here because it's a degree of 2, this is a degree of 1. So what you actually do is you actually do the division here. Okay, we're actually going to divide 2x squared plus 5x plus 4 by x minus 3. Okay, but since this denominator is a linear term, I'm going to use synthetic division. So that's why I do the upside down synthetic division box. So I need to know what number am I going to synthetically divide by. Well, you set your denominator equal to 0, add the 3, so x equals 3. Okay, so that's the number I'm going to synthetically divide by. Then I list out these coefficients, 2, 5, 4, carry down, multiply, add, multiply, and actually this last thing doesn't even matter, so I'm going to ignore it. So bam, my slant asymptote is 2x plus 11. So y equals 2x plus 11. Because you should remember, the last number is always your remainder, which doesn't factor into the slant asymptote. The next thing is your constant, the next thing is your coefficient on x. So my slant asymptote is y equals 2x plus 11. Okay? Moving on. Problem number 26. Describe the behavior around the vertical asymptotes of each function. So I know we didn't do a whole lot of this in class, but you should remember, how do you find a vertical asymptote of a rational function? Well, you just set your denominator equal to 0. So x plus 6 equals 0. So x equals negative 6. Okay? So this is your vertical asymptote. So all the questions asking is what is going on as we look at our vertical asymptote. So in other words, we ask ourselves, as x approaches negative 6, because that's the vertical asymptote, from the left side, so I'm going to say from the left, it wants to know what is y doing. Okay, from the left, it wants to simply know what is y doing as we look at it from the left. Okay, and then we're going to repeat this question, but we're going to say it from the right. Okay, I'm not going to write it all over again. I suggest you do, just like right below, say as x approaches negative 6 from the right, f of x approaches what? Okay, I'm not going to do that because I'm making a video and I'm cheating and being lazy. Alright, so we're going to go here, we're going to say negative 4 divided by x plus 6. Okay, so remember, here's my vertical asymptote. What is it doing as I look at what is y doing as I look at this from the left side? So x is approaching negative 6 from the left. What is y doing? It's going up. So I would say that's going to positive infinity. Okay? So now we're going to repeat the same question, which you should already have written down, but instead of saying from the left, we're going to ask ourselves, what is it doing from the right? Okay? That's what we're going to ask ourselves. Well, when you look at this vertical asymptote, what is it seeing that we're doing as I look as it comes to it from the right? Well, y is going down forever. So we would say that y is approaching negative infinity. Alright, moving on. 27. Same question, just different, same type of question, just different numbers. I suggest you pause, try to do this on your own. So hopefully you're just unpausing and you have your answer. Alright, I'm actually going to bring this back, and because I'm going to be lazy, and because I don't feel like trying to write this out on my keyboard. It's much harder than I think you realize. So, all this stuff. Oh, no. Why can't I select things? Well, you were letting me select earlier. Okay, anyway, what I have right here, apply to 27. Okay, just pretend this is shifted over to being underneath 27. So first off, what is the vertical asymptote from this guy? Well, you set your denominator equals 0, so x squared equals 0, so then x obviously equals 0. So your vertical asymptote is x equals 0. So as x approaches 0 from the left, what is y doing? That's the question at hand. Well, once again, we're going to cheat and let our calculator do the work for us. So it was something like negative 2 divided by x squared. Press graph. Okay, as we look at it from the left side, we see that it is going down to negative infinity. So we say it is approaching negative infinity. Okay, so now I want to ask the same question, but rather from the left side, I want to think about it from the right side. Okay? I want to think about it from the right side. So, go back to your graph. Look at the vertical asymptote of 0. What is it doing as I approach it from the right side? Well, it's going down again to negative infinity. So, bam, negative infinity. Alright, so that's how you do that problem. Let's move on. 28. Solve each inequality. Okay, to solve these inequalities, what you have to do, first thing you have to do, is get your zeros. That's step 1. You must get your zeros. Okay? So to get my zeros, this one's actually all set up nice and easy for us. We're just going to set each piece equal to 0. So we have x equals 0. We have x equals negative 6, because you'd solve, set it to 0 and solve. X plus 1 equals 0, subtract 1, so x equals negative 1. So, now what we're going to do is we're going to make ourselves a type of number line, but not really. We're going to, okay, you guys should remember we do something like this. We say negative infinity to negative 6, because the only time that this guy could potentially change signs where it would not be negative anymore is at zeros. Because remember, to change your y value from being positive to negative, you have to cross over the x-axis, okay? These are the 3 places that I cross the x-axis, okay? So these are the only places where my y value could potentially change from being less than 0 to greater than 0 or vice versa. So we say negative infinity, negative 6, so all the x values on this side of that 0. Then we have all the x values between negative 6 and negative 1. And then we have all the x values from negative 1 to 0. And then we have all the x values from 0 to infinity. Okay? And so now what we're going to see is, remember, we don't care what the actual number is for the y values. What I care about is if it's a positive or negative. So negative infinity, negative 6. Okay? Pick an x value for that. Like negative 3. Great. I'm sorry, that was stupid. That negative 3 is not inside there. My apologies. Negative 10. Okay? Plug in negative 10 for x. You get negative 10, negative 10 plus 6, negative 10 plus 1. So you're going to get a negative number times a negative number, because negative 10 plus 6 is still negative, times another negative number, because negative 10 plus 1 is still negative. So negative 10 times negative 4 times negative 9. Well, negative times a negative is negative. So I don't care about what the actual y value is here. I just care about the fact that it's negative. Alright? Now I pick an x value between negative 6 and negative 1, such as negative 3. Okay? I plug that in. Negative 3 plus 6, negative 3 plus 1. Well, that's going to be a negative. Negative 3 plus 6 is 3. Negative 3 plus 1 is negative 2. So negative times a positive is a negative. Negative times a negative is a positive. So the y value is positive. Okay? Next number. Pick something between negative 1 to 0, such as 0.5. Okay? Well, negative 0.5, sorry. Negative 0.5. Plug that in. Well, that's going to be a negative, positive, positive. Okay? So a negative number times 2 positives is going to come out negative. So now we pick a number that's 0 to infinity, so in between those two, such as 1. Well, that's going to be positive, positive, positive. And that's going to be all positive. Okay. So now we go back to the actual question at hand. It wanted us to be less than or equal to 0. Alright, so what x values gave me y values that were negative? Because that means to be less than or equal to 0. Negative infinity, negative 6. Negative infinity, negative 6. And negative 1 to 0. So that is your answer set. Okay, this is it right here. Bam. All right, moving on to problem 29. Problem 29 is a little bit more of a pain of a problem. Okay, so my suggestion on problem 29 is, remember, since you have x in the denominators, you have to not only figure out your zeros, you must also figure out your vertical asymptotes. Okay, you have to do both. Alright, here's my suggestion. Let the calculator do all the thinking for you. Alright, let's go to the calculator and think about this. Okay, so we go to the calculator. We turn it on. Now, I don't think I talked about this way very much in class. I know I mentioned it briefly, but I'm not a huge fan of this way until I'm trying to pass the test. Before trying to pass the test, I don't really like this way. But when I'm at a point where I'm just trying to pass the test, that means my goal is just to figure out what core information I need and discard everything else. So, hit graph. I just plugged into y equals. I've hit graph. Okay. So, look. Here's the questions at hand. It just simply wants to know, where am I less than 0? It wants to know what are the x values that produce negative y values. That's all it's looking for. Oh, by the way, sorry. Pause. Retract. Not what I said here. This was equal to, so you could have also included a bracket on, so I had negative infinity, negative 6. Negative 6 would have gotten a bracket, and I had, what was the other one? Negative 1 to 0, I think. Yeah, negative 1 to 0. So they both could have gotten brackets. Okay, sorry about that. I just realized. Okay, so going back to problem 29. So, let me erase that stuff. It wants to know where is y negative. Okay, so what are the x values that produce negative y values? Well, I'm negative here, and I'm negative here. So what is this x values? What is the set of all these x values, and then what's the set of all these x values? Okay, well, the set of all these x values is clearly negative infinity to this number. Okay, to this number. So what we need to do is figure out what this number is. Now, here's a trick. Here's how you can use a calculator to help you. Okay, is this a 0? When it turns down this way, is this a 0? Am I crossing the x-axis at all? No. This is some weird straight line that appeared on your calculator. That's a vertical asymptote. How do I get vertical asymptotes? By setting denominators equal 0. So I have two vertical asymptotes at x equals 0 and at x equals negative 2. Okay? So which vertical asymptote do you think this is? That's right, probably the negative 2 one. So I seem to be producing zeros from negative infinity to negative 2. And then, I said producing zeros. Producing negative numbers from those. Now, be very careful. It's not just negative 2 to 0 here on this one. Because what do you notice? On this part, I'm above the x-axis. So I start being negative starting right here. Okay, at that point. So that's a 0, right? Well, you're right. I could figure out my zeros by putting these fractions together and then setting my numerator equal 0. But that's going to be a pain. What else could I do to figure out this 0 right here? I could use my calculator's second trace 0 ability. Alright, so first, I got to find my cursor. I don't know where it is. Okay, my cursor's all over there. It's not on the right guy yet. Hold on. Move it to the left. Okay, it says left bound. I need to be the left of this 0. Oh, let's go back. And is this cursor to the left of this 0 right here? Yes. Press enter. Oh, I didn't press enter. Right bound. Now I need to move the cursor to the right of it. It's to the right of it. Press enter. Press guess. So negative 1.5. So I know from negative 1.5 to something. I haven't figured out the other side yet. To something. Y'all notice how it kind of starts curving. Well, what did you remember? We have a vertical asymptote at 0, which would be this line right here. So that means that I'm probably going from negative 1.5 to 0. And bam, there we go. To me, that way is a little bit easier. I don't like it as much because I feel like I get convoluted looking at the graph. But it's easier than having to put a couple fractions together. Okay? Moving on. Find the maximum of h of t's equal to 16t squared minus 56t. Okay, so look, let me just give you a hint on this problem. Anytime it says find a maximum and then it doesn't give you some weird interval, it's talking about a local maximum. Okay, so what it means there is it just wants you to look and say, okay, what seems to be the highest and lowest? Well, the problem is we can't see anything on graphs like this because they're so big. So let me tell you to go to the window and start playing around with the window, alright? So first off, 97% of the times on tests, the maximum is somewhere to the right of 0. Okay? And let's see, let's choose some reasonable x max, such as, let's try 30. Okay? And again, 90% of the time, you don't even need to change the y values. Okay, I could be wrong. I could be wrong. So let's hit graph. Okay, that looks like we're not looking at much. So let's hit zoom 0. Because zoom 0 is zoom fit, so it's going to make it fit to my new window. That did not work out the way that it was supposed to. Okay, let's try this. Let's go back to my window. Let's not try 30. Let's try 20. Then let's hit zoom 0. That didn't work. Let's try this. Let's try resetting everything and saying just kidding. And let's try starting out with zoom 0. Okay, so did I put this in right? Oh, haha! I'm crazy. I apologize. I am insane. I was looking at an entirely different problem. So, I have work over here to the side that I worked out before starting this. Okay? And apparently the work I have over here, I have an entirely different problem. Okay? So I wasn't really looking at this problem. I was just following my work because I did a completely different type of problem. Okay. So let's go back to the graph here. And it looks like we have a maximum happening somewhere right there. So first, I'm going to go to y equals, make sure I type this in right. Negative 16x squared minus 56t. Alright, that's fine. Okay, it looks like I have a maximum happening right there. So, that's clearly on the negative side. My advice earlier is now stupid. So let's excuse me. Let's change our window. Let's go to window. And let's change my y from being that super negative to just that right there. Let's hit graph. What happens? Boom! Perfect. So look, moral of this story. 1, make sure you work on the same problem that you're talking about in the video. 2, you gotta be willing to play around with your window. Okay? So we hit second, trace. We go to 4, which is maximum. Left bounds. First we gotta find our cursor. Where's my cursor? There's my cursor. Left side. Alright, I'm to the left. Press enter. Right bound. Get it to the right side. Okay, I'm to the right. Press enter. Press enter. I get negative 1.75, comma 49. So negative 1.75, comma 49. Bam, there we go. Okay. Now what interval is the function in question 30? Increasing, decreasing. Okay, so go back and look at your graph real fast. I was going up, 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 and then I started going down, 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 down. What was my turning point? This guy right here, right? So I was increasing all the way to this and decreasing after this. So you can say I was increasing from negative infinity to negative 1.75. And then you can say I was decreasing from negative 1.75 to infinity. Okay? Moving on. Problem number 32. Describe the transformations. Alright. So, I'm not going to write them out because it takes too long to write it out, but I will speak about them. We went from 3 to the x to 4 minus 3 raised to the negative x. So first I have a negative in front of the x. That's reflecting across the y-axis. Secondly, I have a negative in front of the 3. So that means I'm reflecting across the x-axis. And this is a positive 4, so that means I'm going up 4. Okay, problem 33. I went from a log to an exponential. So that means I was an inverse, so the reflection would be, the transformation would be reflecting across the line y equals x. Okay? Moving on. Combine. Okay, so I have 2 log base 8a minus 4 log base 8b plus 2 log base 8c. Well, everything that's a number on the outside can go inside and become an exponent. Okay? So I'm going to have one big log base 8. Then this is going to be a squared. And since it's being subtracted, I'm going to change it to inside the log to dividing. But this guy is adding, so I'm going to change it. It gets to go back on the numerator. And so there we go. All right. Problem 35. Determine the domain. G of x is equal to natural log of x minus 2. You should remember that a log graph has a vertical asymptote at x equals 0. Pretend that was drawn better. At x equals 0. But I'm shifting it to the right 2, so my vertical asymptote isn't at x equals 0. My vertical asymptote is at x equals 2. Okay, so it's actually this pink vertical asymptote at x equals 2. And then my graph just looks like this. Okay, so we could say my domain is from 2 to infinity, but with a parenthesis, not with a bracket, because it's coming from a vertical asymptote. So I never get to include it. Okay, so that's why it gets a parenthesis, not a bracket. Okay, moving on. 36. Let Q represent a mass in grams of carbon-14 whose half-life. Okay, you can finish reading on your own. This is the equation. Determine the initial quantity. Bam, that's the starting amount right there, which is 15. Determine the quantity present after 4,000 years. Take 4,000, plug in for t. Alright, so let's do that. So, second quit. So I'm going to say 15 times 0.5 raised to the 4,000 divided by 5715. Press enter. And I get 9.23. 9.23 grams. Alright. Next problem. Consider the functions. Which of the functions has the property y approaches 0 as x approaches infinity? Alright, so guys, we just did this problem on a prior review. I remember that, okay? And what I told you to do is I told you to plug it in one at a time and simply look and see which one actually had that property. Okay, like that was the easiest way. So negative e to the negative x. Okay, you're going to want to reset your graph here, so hit zoom 6 when you get a chance. Alright, so zoom 6. So yeah, plugged in negative e, negative x. So as y goes to 0, well, which one is it that as x is going to infinity, as x is going to infinity, y is going to 0? Okay, so as x goes to infinity, so that means as I look to the right, is y going to 0? Well, yeah, for this one. So yes. So negative e raised to negative x. Alright, now it is possible that there's multiples, okay? But what I want to do is these two questions go hand in hand, A and B, so I'm going to do both of these questions at the same time. Okay, so for this part right here, negative e raised to negative x, which one of the following does it have this property? Was y going to negative infinity as x went to 0? Okay, so remember, that's asking a different question now. As x goes to 0, where is x 0? All along this line. Okay, is y going to negative infinity when I look at x going to 0 on either side, either the left side or the right side? No. On neither side is that true for negative e raised to negative x. So great. So I'm done with negative e raised to the negative x, and I'm now ready to move on to 2 raised to the x minus 5. Okay? So 2 raised to the x minus 5. Hit graph. Alright, so first one I'm going to look and see, as I look to the right, does y go to 0? So I look to the right, does y go to 0? Not at all. Y is going to positive infinity, right? Alright, so let's look at the next one. As x goes to 0, is y approaching negative infinity? That means, is it going down forever? Well, here's 0. Is this guy going down forever? Not at all, right? So it does not work for either one of those. So 2 raised to the x minus 5 is useless. So negative 4 plus log x. I hit graph. First thing I'm going to check to say, as I look to the right, is y going to 0? Well, this is a log graph. So as I go to the right forever, it's going to slowly get bigger and bigger and bigger. But eventually, it's going to be shooting all the way up. It's going to be much higher than y being 0. So no, it doesn't. Now, let's look at the second thing. As x goes to 0, does y go to negative infinity? Well, look at it from this side. I'm getting closer and closer to 0. What does log graph start to do? It starts to turn, because this is a vertical asymptote, right? You have a vertical asymptote at x equals 0. So what does this guy start to do as I turn? It starts to go down and down and down and down and down forever. So -4 plus log x fits this bill. Alright, now let's try natural log of -x. Natural log of -x, hit graph. Okay, so once again, start here. As x goes to infinity, does y go to 0? Whoa. Oh, this guy doesn't even get to go to infinity because it's a vertical asymptote right here at x equals 0 because it's a log graph. Okay, it's a log graph, so it doesn't even get to go to infinity. So no, it doesn't fit that one. Now look at the second one. As x goes to 0, does y go to -infinity? Well, look at this graph. It's getting closer and closer to an x value of 0. What is y going to do? It's going to go down and down and down and down. So this works for this second one. So the second B actually has two functions that work, but the first one only had one. Alright, moving on. Solve for x. Last problem! I kept this video under an hour if I can solve this pretty quick. Alright, so x is trapped inside the natural log. To solve for x, you have to get rid of the log. You can't get rid of the log until you have the log by itself. So I want to subtract 2 first. Alright, so that gives me 3 natural log of x is equal to 6. Next step, divide both sides by 3. So the natural log of x is equal to 2. Now that I have the natural log by itself, I can solve for x by changing forms from log form to exponential form. So what is the base right now for natural log of x? That's right, it's e. So I'm going to say e raised to, this becomes your power, the second is equal to your input, which is x. Bam. E squared equals x. There you go. Whew. Alright guys, I know that was long. I really tried to explain every problem for you. I hope it makes sense. Please take time to really study. Let me know what questions you have. Send me a remind. Send me an email. Come by for tutoring times. Okay, just whatever you need, come by and let me know. Alright guys, have a great day.